Hi, in this video we will learn about a new operation, new product for vectors in R3. This is called cross product, and then we will study the properties of this product. Let me start right away by the definition. The cross product of two vectors, so the cross product of two vectors u and v, these are vectors from R3, so this is going to have three components and v has three components. So the cross product denoted by u cross v is given by u cross v is a vector in R3. It will have three components, and the components, the way you find the components is this. So for the first component, you have u2 cross v3. Then minus, switch the indices here. So it will be u3 v2. That's the first one. For the second one, you have u3 v1 minus, switch the indices, u1 v3. For the last one, u1 times v2 minus, switch the indices, going to be u2 v1. So this is how you define it. Well, it's a little bit complicated, but it is manageable. There is something that you can use that will help you to keep the formula in mind, is that to get the components of u cross v, you can do this trick, that write the components of u and v next to each other. So first u, then v. This is v3. Then add two first one to the end of this column. So it will be u1, u2, v1, v2. Ignore the first row. Now start from the second one. You multiply these terms cross. This is u2, v3. Minus, you multiply the same the elements from the same row the other way around. So this will be v2 u3 v2. That's the first component. The second component, you continue doing same thing, but now with the next two rows. So it will be u3 v1 minus u1 v3, minus come from there, and then for the last one, this is u1 v2 minus u2 v1. This is how you get the entries of the cross product. So let us do an example before we move to the properties. Example, find u cross v. In this case, u is 1 2, 0 cross 1, 3, negative 2. Very well. So this is going to have 3 components. How do we do this? We'll write 1, 2, 0, 1, 2, 1, 3, negative 2, 1, 3. So these are exactly 2 first rows. You put it at the end of these columns. Okay. Now, for the first one, ignore the first row. Then you multiply these two. So 2 times negative 2 minus 0 times 3. For the second one, 0 times 1 minus 1 times negative 2. And for the third one, this is 1 times 3 minus 2 times 1. And this way we found the vector cross product. This is negative 4, 2, and this is 3 minus 2 is 1. Well, you have to be able to perform this product and know the important facts about this thing. So let me just then start with the properties of cross product. These properties all can be proven using the component definition. The first thing is that, well, the order matters when it comes to the cross product. When you switch the order, you won't get the same vector. You will get a negative 1 of that. So this is not commutative. The second thing in my list is that when you cross U2 itself, it means that the first column and the second column these are the same thing. You can do the computation and you see that all the components will vanish. And indeed, you can show that U cross V is equal to 0 if and only if U and V are parallel vectors. And yes, that's the second property. Now we will start seeing, well, what is the relation between cross product and other products, because you see we have scalar multiplication and sum, vector sums, dot product. We have to see what is the relation between these guys. So scalar multiplication, so when you have U cross V, you can scalar multiply it by K. The result will be the same thing as if you first scalar multiply U by K and then cross product by V. And this would be, you can use 1 as a result, show that it will be equal to same thing as U cross K V. So you can use 1 to show that. So cross product and scalar multiplication somehow work nicely together. How about cross product and vector sum? Okay, U VW. Let me use V plus W. Well, this works nicely. You can do this one again component by component. You notice that this will work nicely. This is the property called distributive. So it distributes, so you will get u cross v plus u cross w. How about dot product? Well, you have u dot v cross w. Note that v cross w is a vector, and you can find the dot product of two vectors. And well, this is a nice thing to have. It's kind of cyclic. So you cannot you can kind of combine cross product and dot product. This is the property. It is just written there, and you can prove it by just computing components of computing the numbers from two sides, and you'll see that they are equal. And the last thing is, this is a very nice one, that if you do have three vectors, you can cross product these two, and then there will be another vector, so you can cross it with the third vector. Yes. In the other properties, we had what's called associativity, which means that, okay, so you can first do two first cross and then the third one, or do the two second one and then with the first one. This says that no, this is not u cross v cross w. It's not associative. What it is an interesting fact, which says that this is going to be a multiple of v, linear combination of v and w. The coefficient of v is u dot w, and the coefficient of w is v, u dot v. Well, negative u dot v, I have to say. And these properties can be used in different cases. The main thing that I will leave it as an assignment for the first assignment will be we can use these properties to get a geometric meaning of cross product. What is geometric meaning of cross product? Well, what do you mean by geometric meaning? Well, every vector, so u cross v is a vector. You can say that, okay, every vector is determined by its direction and its length. What is the length of u cross v? What is the direction of that? So length and the direction. I will get back to that very soon. So this is something that you can use the second and third, sorry, the fifth and sixth properties to show that u cross v, the length is a vector whose length is u, length of u, length of v, then times the sine of theta, the angle between these two guys. So if this is u, this is v, then the length is going to be sine of theta times length of u times length of v. But if you look at this thing a little bit closer, you notice that, okay, you see length of v times sine theta is this height. Yes, so this part is the height of I would say this parallelogram. Yes, and the length of u is the base. If you have base and height of a parallelogram, you multiply, you get its area. So this is another interpretation of the length of U cross V is area of the triangle, the parallelogram determined by U and V. Or you can say that this is the area of the triangle, but you have to multiply it by 2. In other words, the area of the triangle is the area of the triangle determined by these two guys is half of this length. So the area of the triangle generated by U and V. So that's the first. The length is given by that, which is the area of the parallelogram, or twice as the area of the triangle determined by U and V. How about the direction? So this is coming from a very easy calculation that U dot U cross V. So U and U cross V, you find the cross product, then it's a vector, you can find dot of that. This is equal to 0. It means that U cross V is orthogonal to U. Also, you can show that this is 0. And that means that U cross V is orthogonal to V. U cross V, if this is U, V, we know the length. Length is given by the area of the parallelogram, but now it is going to be perpendicular along this line, perpendicular to both of these ones. In other words, this will be either that one or that one. It is perpendicular or orthogonal to both of these ones. But which one are these ones? So which one is U cross V? So this is what is called the right hand rule. So you put your right hand in the direction of U, such that when you open your fingers, it's in the direction of U. So let me just try to draw a line. And then when you roll your fingers in, it is in the direction of V. When it's open, shows the direction of U. When it is you rolling into your palm, you get the direction of V. So from U to V, then your thumb shows where the V, U cross V is. This is U cross V, not the lower one. So let me just erase this one. Yes. So this is how you find the direction. So it is a vector orthogonal to both of them, and the direction is given by right hand rule. Well, we will use these properties to do some of the works we have, in particular finding equations for planes in R2. This properties, specifically this one, is going to be useful. So we introduced cross product, we studied the properties. You have to know these ones, and well, you have to be able to prove some of them. Actually, we will have some of them in the assignment. And yeah, That's the cross product.